This is KB0ASQ, and this is the part one of a new project that we're starting. We're going to be building a Pic-A-Star. You can find that on the, if you look that up on Google, it's Pic-A-Star. It's the, we're doing a couple simultaneous projects right now. What I've decided to do is I decided to build a complete ham shack on my own. I'm not really an engineer, nor could I even call myself an electronics technician. I'm what some people say, I guess we'd call a builder. I can kind of consider myself an assembler. If I have something I need to, some function I need to perform, I usually go out and research on Google. Google's our friend, and find the bits and pieces and assemble them and make things work. So what I'm planning on doing is building a complete ham station from the power supply to the transceiver to rotor controller, 600 watt amp, and a few other station accessories. We're going to actually build them in rack mount cases and rack mount them. Part of the reason I'm doing this is obviously for my own education. We also sell parts like Arduinos and Raspberry Pis, so on and so forth, and I thought this would be a good way of showing people how you can use those particular parts in projects. So back to the Pic-A-Star. Well, before I start explaining that, the other project that we're going to be doing simultaneously is I've got a power supply control center that I'm building. I've got a 40 amp power supply that I'm going to control with an Arduino over the network that will have 4 ports that are be able to turn on and off over the network, and also monitor the source voltage and amperage and so on and so forth. So we'll have some posts on our website that you can follow along on that. Our website is KB0ASQ.com. We have blog posts with this, with links to the videos and links to the websites that are referenced and things like that. Anyway, back to the Pic-A-Star. The Pic-A-Star, the STAR acronym stands for Software Transmitter and Receiver. It was originally designed by Peter Rhodes G3XJP and published in Radcom starting in the August 2002 edition. It has been updated by several people over the years and is still it's still very modern in its operation. The original design included homebrew PC boards. One of Peter's goals was that the builder do as much of the building themselves and learn as much about the design as possible. Since then, it has become easier to have PCBs designed and produced, so now they can be found on the internet from time to time. Peter designed the transceiver in modules so that it would be easy to build and test. Each module was a separate PCB board. If you want to build one, you can still download the templates and make your own PCBs. Glenn, VK3PE, has designed several versions of his Pic-A-Star combo boards. Instead of an individual board for each module, he has condensed them into one or two main boards and a board for the LBF and the power amps. I will be using a combo P1 board that I was able to get from Harold, W4ZCB. I want to thank Harold for getting out in the snow in February to get them shipped to me. One of the updates that has been done to the Pic-A-Star is that the original pick and mix controller has been replaced with a more powerful controller. The new controller is the TRX AVR. In its original incarnation, the Star had only a LCD display. The new controller adds the ability to use a TFT display. I will be using a 5-inch display on this build. There are 3 Yahoo groups, well actually 4 Yahoo groups and a couple websites that you need to belong to or visit if you want to build one of these transceivers. First, the Yahoo group. The first group is Pic-A Project, P-I-C-A-P-R-O-J-E-C-T. This is Peter's site where he has stored the original Radcom articles about the project and the other support files needed to build the original design. The second group is PicAStar users, Pic-A-Star-USERS. This is the group where you'll find current discussions about current and past builds. You might also find someone who has a set of boards that they'd like to sell. It also has a lot of information about new mods and things like that. The third group is the Homebrew-Radios group, HOMEBREW-RADIOS. There you'll find discussions about the power amps, the TRX AVR projects, among other homebrew projects. That group isn't necessarily only for the Pic-A-Star. They have they have information about using the TRX AVR on with other radios and stuff like that. Then the final group is the TFTA_Central CENTRAL group, which supports the color display subsystem for the TRX AVR boards. Finally, you will want to visit www.homebrew-radios.net. This site has information on the TRX AVR project also, and the Encoder 8 board. Now the other website that you want to visit that's pretty important is Glenn's website, which is www.carnut.info. Glenn is the designer of the COM-board PicAStar boards, and he keeps all of his documentation there. He is currently out of boards, but if enough people show interest, maybe we can talk him into making some more. What I want to show you right now in this episode is I'm trying to organize myself a little bit in doing this. So what I've done is I've created this notebook with the little bit of not the little bit, but all of the information that I have so far on this project. Now, the first section of this, if you join Peter's group, the Pic-A Project group, you'll be able to download all the original Radcom articles. It was a 20-part series, so there's about approximately 60 pages in there, and that's what this is here. It goes through module by module on how to build it, and it explains each module and how it works. This is essential. You need to do this first before you start attempting to build one of these transceivers. Now, in here you can see in this particular graphic, you can see the homemade PCB boards that he used and how they're broken down into modules. You can see that it uses an LCD display and some the rotary encoder here, to control everything. Obviously, this has been upgraded with the TFT display. One of the nice things about this particular project is you can set up your own controls on it, design your own controls and everything. So here's a nice picture of the templates that you can download if you decide you want to homebrew your own PCBs. Okay, the next section that I have here, right here, is the BOM for the P1 board the particular P1 board that I'm making. Lists all the parts and everything that will needed. This lists it by part type, and then what I did in this next section is I resorted it by the module section. So as I'm building each module, I'll be able to check and make sure I've got the correct parts for that particular module. Following section, this is a printout of the overlays. I went ahead and printed them out. Right here you can see the overlays for the top of the two main boards, and then the back of the bottom side of the main boards. looking at these overlays, it lists the parts and where they go so that you can make sure that you get the parts located correctly. Now, what you want to do, these are off of Glenn's site. You want to download that particular PDF to your computer. I have a computer with some larger displays, and I'm in my 5th decade right now. My eyes aren't quite as good. So what you do is you download the PDF, and then obviously you can enlarge the PDF on your display so it's a little bit easier to see where what the component values are and stuff like that. And that's the 2 main boards. Here's the other boards, the power amp boards, the LBF board, and then this last one that I'll show you is what they call a buzzer board. And what this was designed by W4ZCB, and it's a low voltage board for testing the modules as you complete them. It's low voltage, so you shouldn't be, if you have something installed incorrectly or whatever, it shouldn't cause any damage to the components. Now, then this next section that I have here are the actual schematics for my board. Again, it's the P1 board that I'm working on. The final board that I believe Glenn put out was the P2A board, but I was able to get a hold of a P1 board. There's very little differences between the P1 board, the P2 board, and the P2A board. Just a couple component changes and stuff like that. So functionally they're equivalent. Now the P board, the original combo boards that Glenn designed, most everything was on one board except for the amps. Then he designed the P boards, which the P stands for portable. He had some calls from people to make smaller boards so you could stack them and put them in a smaller case and make it a little bit more portable or mobile. So that's what the P boards are. And then this final section here is the interconnect diagrams, and basically that has the diagram for the connections between all the boards and everything. So that's my documentation. Now, I just kind of wanted to show you this. This is a rack mount case. I bought these from Circuit Specialists. This is actually what I'm going to put the Pic-A-Star in. It's a 4U case. I've got some 2U cases that I'm going to put the power supply in and some of the other options, and then the other 4U case that I bought, I'll be putting in the 600 watt power amp that I plan on building. The final thing I want to show you here are the actual PC boards themselves. Now, I have, this isn't my first rodeo. I've built several kits. This is by far the most complex project I have built to date. But I have built a Sienna transceiver by DZKits.com. I've built a Genesis G59 SDR radio. And then I've also built a Hard Rock 50 amp and tuner. All very nice kits. And the reason I bring those up is the quality of these PCBs are every bit as good as those kits. Now, obviously, the complexity on this one, it comes from the fact that those were kits, and so there were step-by-step instructions on how to set them up or install the components. The components came with it. In this particular project, I have to source the components myself, which adds an extra level of complexity. Also, the option, there's a little bit more options on how you can build it. And the other thing that makes this a little bit more complicated is there aren't a whole lot of through-hole components. A lot of them are SMT or SMD components. Now, these PC boards are very high quality. I'm very impressed with these. There's the top part of the first main board. And the other thing that you can see on these is, even though Glenn combined all the modules into 2 boards, 3 boards, each module is still a separate section on the board. There's like the opto amp. This is the LBF board. I'd have to look at that. This is the DSP section, so on and so forth. But they're all set up in modules, so you can still build them as modules and test them as you go along. So we have our first main board. Again, we have the second main board, same situation, very high quality. And then now these first boards I'm going to show you all come if you get a set of Glenn's boards. And then I'll show you one other board that we'll explain later. But there's our two main boards. Then we have this is actually the LBF board. I'm sorry. Here's the LBF board. Then we have the USB extender, and that's so you can mount a USB port on the outside of the case. We have W4 ZCB's buzzer board here, and then we have the G3XJP's opto encoder board here. And when I get to building these, I'll have to cut those apart. Then we have these two boards. This is the 20-watt amp. Let me turn that back over a little bit. Designed by G6ALU. The PC is by Glenn. There's a 20-watt amp. Your transceiver puts out, I'm not sure what wattage goes into this 20-watt amp, and then the 20-watt amp drives this 150-watt amp, again designed by G6ALU. So we have those two. Then the final PCB that I have at this time is, let me turn it upside right, is the TFT driver board, and I got that from the gentleman that designed it. I'll give you more information on that as we go along, but that I had to buy separately. One of the things about these boards is they're designed to use either, I hope I get this right, the 1206 surface mount parts or the 805 surface mount parts, the way the pads were designed, so you can use either one. This is the first. I've done some surface mount soldering, but this is the first time I've done this amount, so that will be an interesting experiment, I guess. So anyway, that's where we're at right now. The next episode, I'll have a little bit of information about ordering the parts, and then hopefully we'll get to actually mounting some parts on the first PCB. So I hope you guys find this entertaining and informative. And if you have any comments or suggestions, I'm more than happy to reply to them. If you can help me make this thing better, that would be great. So check on the blog again. It's KB0ASQ. We have blog posts on this, and that's it for now. This is KB0ASQ signing out.